You're learning Houdini and you feel stuck, don't know where to start. And you maybe think that you have to learn everything about attribute, vex or loop in order to do complex stuff. You are wrong. I will guide you through simple steps to convert a box into a detailed sci-fi crate, and you will see that you can get pretty complex results just by combining a few simple nodes. Let's see how we can do it from scratch. So here we are. We start with a simple box. The first step is to isolate all the panels, and to do so we could run through a loop, or we could simply use the PolyExtrude node, because here we have a primitive per side, basically, and what we can do is use the connected components here and divide into individual elements. This way, when we will use the inset, it will run individually on each part. And to do so, here I use an inset, and to get rid of all the other primitives, I will just here uncheck output sides, and this way I just get the center parts, so I can separate face isolation. Here I isolate faces, and then I will use another PolyExtrude. This time I will inset the faces to create the shapes of the different panels. This one will be in panels. We just use the inset with no specific options. And then we will use the same technique to separate each panels with a PolyExtrude. I use a PolyExtrude, I inset with individual elements and uncheck output sides. And then here we can start seeing the panel shapes. Here I need panel separation. The corners are very sharp, and to make them smooth we will use a PolyBevel, and this time we need to apply the PolyBevel on the points to basically smooth the points. So here on the group type I will select points, and this way I can bevel the points. We will add some division to make it more detailed. So now we have the basic shapes for the panels. Here we name it round corners. So now we will need to add some thickness, so we will use a PolyExtrude and extrude this. And don't forget to check the output back. So now we have our basic shape. What we want to do is to use this shape as a subtractive shape to get the panels on the box. So we will use a Boolean, connect the first input of the Boolean to our base shape, and then connect the other. But here nothing happens, because if we check here we can see that we need to offset inwards the shape to basically set the proper depth of the Boolean. For this we'll use a peak. A peak basically offset the surface according to the normals. Here you can see that the peak will offset. We use a negative offset to add more depth and then create a shape inward. And here you can use a bevel on the first box on the base to create the shape. Here, just name it offset surface, thickness, bevel edges, and create a network box to make things nice and clean. Here on the color panel we can change the color to make it more visual. So now we have the body, and to make some interesting shape, the shape is orthogonal with the surface, so we will just here add a bit of inset, negative inset very slightly to make the shape a bit more interesting. Don't worry about the normals, we will check the normals later. I can drop here a normal node, drop the cusp angle, and there we go. Here we have our base shape, and we can as well add a PolyBevel to make all the hard edges more smooth. Here we need some exclusion, because otherwise it applies to every single edges. So with the exclusion we can ignore the edges within a certain threshold, and if we crank up this, it applies only to the hard edges and just skip the other edges. So here we can crank up the cusp angle and set here the weight method to biface area, because it will basically flatten all the flattened areas, because otherwise we have some messy stuff, but with the weighted faces it's way better. So here is the base shape. Now to create the corners, we will create separated part of the graph here, and to be more clear and efficient, sometimes it could be cool to reference these parts without any network connection. To do so, we use an object merge. It takes an object here and we can just drag it inside to reference this object. So here it is basically a reference of this one. What we need to do here to get the corners, I will cut every corner with a grid. So I create a grid with two rows, just a simple grid like this, smaller, and we will copy 2 points on the grid. So in the copy 2 point. So the copy 2 point will basically copy the first input to every point of the second input. So here we will copy the grid on each point, but we need to modify. We will need to modify the grid. Basically, we have to change the grid orientation, because when you use the copy 2 point, the alignments of the object is the up axis is the Z axis here. So we need to align the plane with the XY axis. So that's what we're gonna do. So now the plane is properly aligned with the corners, but what we need to do now is to offset the points inward to be able to cut the corners. So to do so, we will use a peak, and the peak will offset the points inward, so we will be able now to cut the points. So here we will use the base, and we will use a Boolean as well. So in the first input we use our base object, and we will cut with our planes. Here you can see that we cut our object, and what we want to do now is to get rid of these parts, the middle, and to do so we will use a delete small part. Delete small parts allow to delete the smallest part in an object, but in this case we will invert the result to delete the biggest one. We will delete the corners and then invert the result to get only the corners. Once we get them, we will merge with the body to check what's the result so far, and we have to offset them a bit because they are at the same place, so the result is not good. So we will use a small peak, and we will just offset slightly the surface. Then we will use a PolyBevel on the points to make this more interesting. Just PolyBevel everything to make some interesting shape. Make a network box for all this and name it corners. And finally apply the PolyBevel. I will name it Polish bevel, and then the normals, and there we go. And the beauty of this is everything can be changed, make different shapes, different panel size. You can basically go to any steps and change some parameters, get different results. That's the power behind procedural workflows. And actually the graph is quite simple, nothing fancy, no loops, no attributes, everything stay quite simple, and I hope it helped you. So if you liked it, like and subscribe, drop a comment if you have any question. See you in the next one.